Okay, I hope you all can hear me, and in the interest of time, let's get started. So welcome to this meetup on the This Week in Machine Learning, on specifically the Fast.ai deep learning, the new version, which is the version 3. As you're all aware, we are doing the second meetup on the lesson 6, since we did not have a lesson lecture this week. And we basically would like to go through what we did in lesson 6, plus take up additional things that we would like to discuss today. So what we have as an agenda for this week is this: of course, have an intro about what TWiML is, have a brief discussion about the study group, what we did last week, what was covered in lesson 6, plus what is available for discussions this week. So this week's is predominantly more about discussions rather than about mini presentations. So Unit 27, which is Sanya Bhutani, would be talking about his Kaggle competition experience. I have taken up a Kaggle competition myself called the Humpback Whale competition, and I would like to kind of introduce it to all of you as to what it is and what we are doing in that. Plus, I think last week we also started the discussion on what we would like to do in terms of taking this forward, what we are doing in terms of the study group and how we can take it forward. And I believe at TWiML, which is Haider, has put together a document on the various competitions. He's taken a lot of effort to put that together. So maybe we can kind of take that up and discuss as to how we want to align ourselves and basically form groups, subgroups, whichever be the case, and take that forward. That's the kind of agenda that we have for today. Having said that, at any point of time, if you have an interesting discussion to kind of talk about or take forward with, feel free to join in and ping us on the same. Okay. So as you all know, we started out on the 27th of October. Here we are on the 8th of December. We have a policy of rotating hosts, and every week is kind of rotated. Some people have done more than once, and we conclude this particular study group on the 15th of December, coinciding with the last lecture, which will happen next week. And the study group on the same would happen towards the end of the week, which is on Saturday next week. So what is the goal? Of course, is to provide support and encouragement, be a community where people can ask questions, get results, understand that it is not overwhelming or intimidating to ask a question and get an answer for it, so that we all learn together. And I personally, as I have said before, I'm a recipient of this course, that it really helps us when it comes to being together and sticking together on this. Okay, so the format, as I was explaining, is that of rotating hosts and mini presentations or discussions. And each host who would do the presentations would reach out and ask for mini presentations and roughly organize with the same. The basic aim is to keep pace with all of us who are all Fast.ai Live participants in some way or other, and to discuss the homework and projects. So these are the study group schedules. We started out with a lesson in October 22nd, with a meetup on the 27th, and we have proceeded. And as I said, we will conclude on the 15th of December, which is next week, with the last lecture, which is on the 12th of December. Okay, so what did we do last week? So we had, of course, a discussion on lesson 6. And Jeremy did start the lesson of lesson 6 with a discussion on platform.ai. And then he went on to discuss a couple of other things. The Rossmann Sales Prediction Challenge, the deep dive on the CNN, where we did the hooks and kind of understood what's happening at the inner layers of the convolutional neural network, and how we can see what kind of outputs are getting back in that particular layer that we are of interest for. And we had a great discussion, I believe, in terms of ethics in data science. And if I really sum it up, the point of summing up for me was the fact that when Jeremy mentioned that it's about 0.3 to 0.5% of the population of the world who can code, and people who are specifically proficient or who are interested in deep learning is again a fraction of that 0.3 or 0.5%, whichever way you look at it. And therefore that places a higher amount of responsibility on people like us, plus people who are already there in this particular field, to be able to have that perspective in mind that what we are developing or what people are developing in this field should be devoid of any bias, should be devoid of any perception that we hold on to, knowingly or unknowingly, that gets reflected in the algorithm that we build in, and thereby goes on to actually have an impact in people's lives, right? Some of it is, unknowing, unwitting, and some of it is really, really there for us to see. So that was a great discussion, I believe, that we had, last week. So that's kind of something that, we want to avoid and be a responsible citizen, so as to say, in this particular domain, to take it forward. Okay, so what did you do last week in terms of the Rosman challenge? It's kind of detailed there. It's kind of the same slides that we saw last week as well. And I just kind of put it out there for you to see, and then and jump back, and kind of respond if you want to take that forward. In any case, so this is what we discussed in terms of Rosman challenge. This is what we had in terms of additional things that we learned, dropout in the embedding layers, batch norm. And of course, this is of course personally for me a great revelation as to how we can call up hooks in Fast.ai and be able to see what happens in terms of the layers and see that as heat maps as to what portion of the picture in each kind of image we are focusing on and deriving our knowledge or our input, and then being able to predict with certainty, with some degree of certainty as to what that likely output is, right? And the output in this case happens to be the class and of the particular pet, but it could be varied for different reasons as we go along. Okay, so that's the kind of overview that we had of last week. What I will do now is kind of keep it open to discussions for all of us to jump in. If anybody has a specific thing that they want to discuss on lesson 6 that we would like everybody to kind of address, we can take that up as well.
Hello. Background noise. Yeah.
Okay, so I'll mute all, and people who want to speak then can unmute themselves and kind of take this discussion.
It's under manage.
Yes, I'm doing that, but unfortunately, it's not muting.
Can you mute just one participant at a time, maybe?
Trying that. Okay.
Yeah, I think that's good now. Thank you.
Okay, great.
Yeah.
Okay.
Yes. So,
yeah, go ahead, Michael.
Yeah, so last week we talked about lesson 6. This week there was no lesson because Jeremy was in the New Reaps conference. I was trying to also catch up with the conference a little bit, and there was one quick presentation that was talking about the transfer learning, and I've pasted that picture on the Slack, and the conclusion they presented was that the weight transfer, so this is what we use mostly in Fast.ai, they concluded is the least effective method, and they've concluded that the adapted embeddings, which I'm not quite sure what that is, there's a link to paper as well, that the adapted embeddings outperform every static embedding method previously proposed. So it seems interesting, and I wonder what's Jeremy's take on that, and whether that's going to be, if that's indeed the case. They basically showed that indeed the the weight transfer, though it's really already good, but there are better ways to do transfer learning according to them. So I wonder how the library is going to maybe change after the conference. Did anyone also see any videos? I know Facebook was live streaming the conference. There were a couple of interesting talks.
Yeah, that's kind of interesting, as you said, right? So maybe in the next version of Fast.ai, which is maybe recent to come up, but we will have discussions on adaptive web meetings and how it is different. But then, yeah. The kind of revision changes that we've seen with Fast.ai, it may happen sooner than later, and a lot of things to look forward to. I was also looking at a tweet this week by Jeremy, maybe just about a few hours back, where he was talking about decent data sets for NLP, right? And he was specifically mentioning that he was looking for such data sets for NLP for his students, and he's not able to get quality data sets that he could take up and take it up as a discussion point with his students. And I would assume that that refers to the recent batch of Fast.ai, whether that is Fast.ai Live, us, or people who are doing the course in USDF along with him, right? So that's also something that I found was interesting in this week.
Yeah. I'm also looking at the chat. There's a question about hooks, how they work. I'm not quite sure myself, so I would like to know that as well. If anyone wanted to give like a short.
Yeah, it's yeah, because I saw how they built it in the last library. I haven't looked so much in V1, but I think it's similar. You can add, like PyTorch has capabilities where you can add a forward hook. And so the Fast.ai hooks, I think, wrap that functionality, and basically at any layer of the module, you can get the output from there.
Okay.
Does that kind of make sense?
Yeah, on a high level, of course. Need to dig into kind of understand it, but sure, thank you. Mm-hmm.
So that means, like, for example, if you want to see the different parts of your convolutional layer, then hooks is the way to go about it?
Yeah, that's what you would want to use.
Okay.
Another question I see on chat is about the part 2, which we've learned starts March 18th. So far, we didn't see any registration for that. That was another question. So I guess we just need to wait for that.
True.
And then we were talking about what to do in between. And I think we did a couple of polls on the Slack channel. So I think conclusion was that we want to do some Kaggle competitions. Is it correct? Who did all those?
Yeah, Haida, you did all the hard work. Do you want to report on what you found?
Yes, Haida, that would be great if you can, take it up. So if you want to bring up the sheet that you forwarded to all of us, I can bring it up. Or if you want to do the same, it's good as well.
I will share my screen if you don't mind.
Sure.
So here is the Google document that I shared with you.
Haida, you're a little quiet. Could you speak up a little bit or adjust your microphone?
Maybe this is better, like this. Do you hear me?
It is good, but you can, if you can increase the volume a bit, it will help.
Just a minute. I don't know. It's 100% the level of the headphone.
Maybe keep going and we see how it is.
Yeah.
Go ahead.
One moment. Recording, microphone array, levels. Yeah. I think now should be better, right? Now
Yeah, it's better. Yeah.
So this is the Google document that I shared with you. I think basically we have 7 types or 6 types of deep learning models that we studied in Fast.ai course, the first course, part 1. The computer vision, which we have the multi-class and multi-label classification, and the segmentation problem, and the speech recognition, which is, I think, also the computer vision, because most of the solutions that I have seen, they turn the waves into spectrograms, and then they use CNN to analyze segments of this sound. And the second one is structural, which is either time series or other types of structural data, and also the collaborative filtering, NLP and GAN, and multimodal combinations, which is, I found it very interesting because it will combine all the models that we've studied into single competition. And we have also live competitions, but I don't know whether all types will be there during our study in the during the 2-3 months in between the 2 parts of Fast.ai. So I try to collect the competitions that we have found some solutions for them. Like here, for example, the RSNA pneumonia detection challenge. The first winner was one of the Fast.ai students. His name is Alexander, and he was pretty active last year. He promised that he will share his solution. So I found this is interesting because in case we try our best and we did not get good results, then we can take a look on some solutions that other students in Fast.ai they solved it, and especially if it is a winner solution. So that's one of the things that I see it's appealing to get competitions that's already finished, because I think people are sharing openly their solution. So in case we want to learn, maybe it is better to take a look for winning solutions. Of course, you can argue that live competitions also has this feature that we can take a look on the winning solution after they finish. But I think that's true. But maybe the number of the competitions will be much less than the past competitions. So I put here a few of the interesting competitions that in next step, we should make a poll for each category to choose one of them. Of course, because we've agreed on bi-weekly Kaggle competitions, so I think there is not enough room to take all the categories. As we see here, we have 7 categories, but the 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 types of competitions, and we have only 6 bi-weeks. 12 weeks and every 2 weeks, so six competitions that we in poll. In a poll, we should choose 6 from these 9. Most of the fellows agreed that we would choose a past competitions and plus 1 live, which will be in parallel with all the others. So I think if we see the poll here, so the question is, you prefer the meetups after Fast.ai course as weekly just one, bi-weekly 2, bi-weekly Kaggle competitions, but weekly meetups to discuss progress. Most of the people here agreed on this third one. And we have this poll also, the past versus live competitions. And most people agreed on multiple past competitions plus one live competition throughout the 3 months. I think the next poll would be next week about choosing 6 past competitions, 6 categories from these. These are 9, we will choose 6. So most votes, we will choose the most votes on these 9 categories.
Because also we could like form groups, like smaller groups, and then by interest, so everyone can have different interests. So someone might be more interested to visions, someone might be more interested to NLP, and that's fine, right? That's fine. So maybe you could do like a groups and then team up on Kaggle, and we could do that like that as well. So like we don't have to all of us do exactly same competitions. I think.
Yeah, it's a good idea. Good idea. One downside in this, in that we are not a lot. I think the interested people here is, I think there are 20, around 20, maybe 1, 2, 3 to 25, maybe. If we make it like a 3 groups, maybe each group will take around 6, 7, right?
Okay.
Is it okay to make it 2 or 3 groups? But I don't know, but maybe if we agree on a one large group, the learning experience will be better. This is the good side. Or bad side, that not all people are interested on all these. So I don't know. It's up to you.
Just one question on that. What if we so what if we had a Slack channel for, like, say, if you were interested in computer vision, you had a Slack channel for that. Now I don't know what we do exactly for the, you know, for the Kaggle bit itself, but at least everything on that discussion around computer vision could be there. And then if you had another one for NLP and so on, I mean, just for these few weeks. And then that way anyone can join whichever one they're interested in. But I'm not sure how, so I haven't taken part in a Kaggle competition, so I don't know how that would work with regards to actually, you know, working together in terms of Kaggle itself. But at least sharing stuff on that thing should be possible. But open to other suggestions.
So let me just pitch in here. So I have been starting along with another Fast.ai teammate here, the humpback whale competition, right? And it's a live competition. It's a multi-class competition basically that we have kind of enrolled in. So a couple of things that I want to kind of point out. One is the Fast.ai library, as good as it is, it's not going to get you great scores first time around, right? It's going to give you a decent score. That's my experience. And of course, there's a lot of, at least going into the library that I had to do to get at least the initial baseline version working. So that's point number 1. Point number 2 is a lot of, you know, interactions used to happen within the Kaggle teammates as to what are the ideas that we need to kind of exploit and kind of hypothesize and see what are the scores that we get. So in my opinion, what I have seen is it's best to have a smaller group that you can work with, that you can kind of talk to, you know, split work together and do that. When you have a larger group, and again, that larger group is spread across multiple time zones, that becomes a kind of, you know, point of concern, especially when you want to achieve a lot of things within a short amount of time. That's my, you know, what I should say, understanding that I have in the last 3-4 days that I have done this particular Kaggle competition.
I think you are right about this. Only one question: how about making it as a closed group and then open it after finishing your 2 weeks? Because I think it will encourage more participation from every member. The problem of opening the channels of the Slack for everybody is that it will encourage lurking. You know, maybe I have no time to work. Other people also, they will not encourage to participate. So how can we decide that who is participating? I mean, this competition should divide the work on everybody participating. I mean, you know, I shared one of the good examples of team working of a Kaggle competition. I think it is here. Yeah. He said that there is a manager of the team, and he will list the ideas that should be done, should be worked, and each one of the members will pick up one of the tasks from the list. So I found here. Yeah, this one. So the communication between the members is via Slack and via Slack and private Git, like Bitbucket or GitLab. And the task splitting, one blender, he means making ensemble blending for multi-models into one final result. One or two person is responsible for all the stacking, blending, ensemble thing. Blender will also manage all team submissions. He will make the submissions. And also list every idea we need to run or try. Then the team, the workers, will consume it based on their skill and hardware. This list of ideas will be updated along the competition. Also communicate the problem and result and change strategy if we need. So I mean, members of such team, so that it will be collaborative, all should work together. I mean, you should make it somehow, this arrangement. So what is your idea about this?
Yeah, I think it will work. So if you want to also stick to the competition rules, then we need to kind of some sort of everything that you share should be shared publicly, I think. So like either Kaggle kernels discussion or wherever GitHub. And then, yeah. So I think maybe that's one point to add.
I mean, I guess part of it depends on how much we're going to be doing like past competitions versus like a live competition. Because if we do the past competition, then like the rules aren't like it doesn't really matter where you share it or whatnot, because like it's already done, right? Nobody's going to win. And I feel like for the past ones, we also would want, like, people wouldn't necessarily need to do blending and ensembling if the point is for them to I guess if the point is just to learn like computer vision, that kind of thing, you don't necessarily need to do the ensembling. That's really what you would only do that if you want to get kind of the extra performance in order to win. So, you know, I don't know. There are some benefits to doing the past competitions. I would say there's some different considerations there versus doing one that's live.
Yeah.
Yeah, this is one important point between live and past competitions. In live competition, you are eager to take higher ranking and you will do everything. And it will be time consuming. But for the past competition, you are more relaxed and you are concentrating on learning. So it's not important to make ensemble things and stuff like that. So I think, and one more important thing is that you can see much more solutions in past competitions, and you know 2 weeks is not too much. Within 2 weeks you should wrap up everything and you learn everything. So
yeah, I guess everyone's different as well. So like for me, the live competitions, and also the fact that I don't see all the answers and I have to find them myself, kind of like encourages me to kind of like find it out. Whether I have everything like solved for me, I would not go into that trouble to kind of figure it out why it works. So kind of, in my case, I guess the live competitions kind of work, I think, better. But I agree, there might be someone who prefers learning from past. So I think that's fine. So we can find that naturally that split.
I agree with
That's a
Michael
good
there.
point. That's a
I
good
think
point.
you can learn a lot more from a live competition than from looking at other people's solutions. And I mean, I think there's things to be learned that way too, but
Audio stopped. But I think that's fine. There's plenty of competitions to choose from. So I think we could just choose whoever, you know, and then team up. Might be also nice to learn in a team, and then see how it works. And then we could each week as we meet, we could present, of course, if a team is going to win and they want to share everything they've learned, of course, they're fine to do it. They can just present things they want to present and keep secret for things they want to keep secret. So I think that should work. And if someone,
and if you have say four teams or something, 5 teams out of the 20 of us, and one of the teams might want to be doing live and the other ones might want to be doing different of the past competitions, that would be great too. I mean, I would certainly, if I'm doing the live competition, I would certainly be interested in what people as well.
Yeah.
Yeah, that's a good idea. I think I agree also. Yeah. Yep. And you have a good point on the live competition that you are trying to do it by yourself. I felt that also on the doodle competition. Yeah.
Yeah.
So what would be interesting and helpful, in my opinion, Michael and Haider, is, you know, can we have some sort of guidelines that we can put together for the group, one who are doing the archived competition, so as to speak, and one who are doing the live competitions, so that we are always in sync with the spirit of Kaggle competitions, right? We don't share it in a forum that is not in Kaggle, or we kind of overrun, we risk overrunning any such norm. So that would help the participants to kind of get this accustomed with the norms and thereby be consistent with the Kaggle terms and conditions.
Can someone bring us up to date on what these general rules are if you're in a live Kaggle competition? What is, in general, what aren't you allowed to do?
I think generally, to what I know, is like, if you want to share something with like a solution, you should share like with everyone. If you have like external data, you should share that data with everyone.
With everyone on your team or with everyone in the entire competition?
Entire competition.
In the forum.
I think that's a misunderstanding, because if you work as a team, you don't have to share it. You can only share it between the team, and the team can only submit as a team. So if you keep it in the team and only submit as a team, you don't have to share it with the outside.
Yes,
yeah,
of course.
I think that's right.
Everything is possible inside the team. You are just like a one person inside the team.
Yeah. So either share only with the team or you share with everyone. I think that's the kind of like, that's my understanding. Yeah.
So how can we do the organization of such groups? I mean, how do we start with a certain competition? Should we poll on? I mean,
we could use the doc on the shared doc that you create, and then we could start writing the competition, and then we could assign, so everyone would choose which competition they would like to work on for the next couple of weeks, and then put the name beneath that competition, and then that will be a team, right? If like 3-4 people put a name on one competition, that's a team. Or if they want to work as a team, they still might want to work as an individual if they want to, right? If they want to win alone and get all the prizes, that's also fine.
So I think you mean we make a poll for all the competition names, and maybe 3 or 4 will choose the first one, 3 or 4 choose the second one, and so on. So it's automatically grouped. The first one with the one group, the second one with the second group, and so on.
So can we
every 2 weeks there will be a week every 2 weeks, right?
Absolutely. So, but can we kind of generally agree that when we talk about archive competitions, it's generally okay to kind of come and discuss here with everybody, even they may not be a part of the team that we are representing as is in Kaggle. But when we talk about live competitions, before we discuss here, we make sure that the person who's discussing that competition or discussing their approach to the competition has that in a Kaggle kernel somewhere, right? So that we don't violate the kind of spirit of the Kaggle itself. Is that something acceptable, TWiML?
I didn't understand for the live competition. What should the group do?
So basically, if I understand right, for the live competition, there are two ways, as Nikhil just put it, right? So one is, if you're a part of the team, then you can share it with the team, no problem. There's no violation of any norms. But if you're not, and if you're sharing it to everybody, then make sure you're sharing it to everybody. That would mean that it is available for public in a Kaggle kernel, right?
Right, or in the forums, yeah. Yeah, I think in general, like, yeah, I think if you're discussing ideas, they should be only things that have also been, they're publicly available in the forums, yeah. Or a kernel, yeah.
Yeah, so we basically, it's in good spirit. We ask the person who's discussing the live competition just to ensure that before they discuss that with us in this particular forum, they have that in a Kaggle corner or in a public forum already, so that it's then easy to kind of make sure it's within the Kaggle norm, so as to say.
And the group that is working on live competitions, they should share for us. What is their motivation to share?
I'm just saying, if they wish to share, right, whomsoever is in live competition and they wish to share, they would do so after having done it in a public forum.
Yeah. And one more thing is that live competitions, it will be done every 2 weeks also. Is it that possible?
I think, after having the teams and the competitions that they choose available, we can kind of schedule that and ask if they're willing to discuss, and if they are, then we give them slots for every bi-weekly meetups that we have.
Yeah, I think okay.
I think once we have enough competitions and different people doing different competitions, we can kind of every week or every 2 weeks give like feedback, what you've learned, what you found useful in this way. So like, if I'm not going to cover all the topics learned, I think that's also be fine, because that's a lot to, as you pointed out, there is like a lot of topics, not enough time. So you could either like do one competition per 2 weeks and learn something, or you could spend like an entire 3 months on one competition and learn like in depth in that topic, which is also fine. I guess that depends what you want to do, and that could be also individual decision, I think.
Yeah. I think the live competitions would probably be more, you'd probably be more likely to spend the whole time on the live competition, whereas on the already archived competitions, you would learn a lot faster, and because you would be able to take advantage of what everybody's learned. So you might be able to actually wrap it up in 2 weeks. I don't know.
Yes, a couple of things there, right? So if it's a live competition one, you're not going to have a lot of people sharing the solutions with you in the Kaggle kernels. So you are then forced to think on your own feet originally and come up with something that would get you a better score. Whereas in an archived competition, you probably have access to kernels that are higher, have higher scores, and you may have a tendency to skip the thinking process and directly getting into the solution process to understand what is it that somebody has done. So that may be something that we may want to be aware of. But yes, generally speaking, the archive competitions could be looked at in a bi-weekly time framework, and the other competitions on a longer time framework.
I think maybe we can do it in a dynamic way. I mean, every 2 weeks we can arrange something. We can discuss what should be, what can we do with the next 2 weeks. So I think because last week I thought that we can make a solid plan for the 3 months and divide every 2 weeks. What would we do? But maybe it's better to make it some dynamic arrangement every meeting. Yeah.
So I think so, because even with the already completed competition, some of them are maybe easier than others, and some of them you might want to keep going, you know, for another 2 weeks or really understand more about it.
So let us agree on what type of poll that I should do next week, because you know 15th of December I think it will be the end of the course. We have these 2 weeks between 15 December and 1st of January. So what is your plan? What poll should I do?
What about if we start forming teams? So what about if we just create a shared doc, and then on that doc there will be competition, and then we could say who wants to take this competition for next say week, 2 weeks or whatever, and then whether that person wants to be in a team, like a yes or no, and if there's like a couple of yeses, then these guys can form a team. So then we'll have like a list of people and competitions and teams, and then we can just review on a weekly basis the learnings, I guess.
So you are suggesting that the competition names, I make it in the poll, and then we will see how many groups will be created from the poll. Yep.
Yeah, and what you could do is with what you already have, you could add another column there and have people put their names next to the competition that they're interested in.
And the next column, whether you want to be part of a team or not, I guess.
Yeah, I think the poll is already they will assign the names that they choose, as you see here in the screen. So we have Shaheen, he chose the first one, William Horton the second. So I think the poll is already assigning the names on the. Maybe you mean after the poll I will add the names in the doc. Yeah.
No, you could collect the names in the Google Doc. People can just add their names, and you add another column to the Google Doc for names, and then people just add their names under that column for the ones that they're interested in.
All right. I will do that.
Yeah, that will work for me. Yeah.
Yeah, I think that's a good suggestion. Yes.
Yep. All right.
Okay.
Maybe I have this this column. I just resize it.
Yeah.
I have this column. I resize it, and people can add their name here.
Yeah.
Anyone on the call already participated in a Kaggle competition as a team?
Yeah. So as I was mentioning, Mikkel. So myself and Unit, we have participated in the humpback whale competition, which is a live competition.
Okay.
And that's ongoing. And
nice.
So we've started that particular process, and what I can talk about it is that we really did have to face a quite bit of challenge in getting the Fast.ai library to work and resolve into the test and valid set. Sorry, the train and valid set first of all, to get that working. And after having tried whatever we knew, we have ended up at a score which is like 50% of the top score, right? So there's a lot of things that needs to be done, a lot of hypothesis that needs to be kind of validated as we go along. And that is the important part of this competition, right? So that is something that we must keep in mind. And from whatever I could see in the Kaggle kernels, majority of the winning of the top scores have come from pure PyTorch implementations, not necessarily the Fast.ai ones. And I've not seen a Fast.ai implementation of the current version as such for that particular competition as of now.
Sorry, which competition was this again?
This is the humpback whale competition.
How do you spell that?
HUMPBACK, humpback whale.
Humpback. I got it. Yes, humpback.
I remember there were a problem in the skewness of the data. I mean, not all classes have enough data, right?
Exactly.
Yeah. So how did you manage to solve this issue?
Absolutely. So just as a high level, what we did was we went through a couple of Kaggle kernels to see what they have done. And what we did was we replicated the images again for each of those classes which had less than 10 per class, for example. And then we kind of created the train and the validation sets from those additional images. But having said that, even after having 93% accuracy, we didn't get great scores in the competition with the Fast.ai.
How much was the accuracy?
About 93%.
93, nice. Is it the same humbug competition that is live now?
Yes, exactly.
It is the same?
Yeah.
Because I remember it's something like similar competition was before, or is it...
Yes. So what I understand is there was a playground competition before.
Yeah.
I believe the data sets are very similar from what it was in the playground competition before and the current one right now.
I think what I remember from the old one, the key was to, because like on some pictures, those you didn't, like the pictures that we saw were like very large, but some of them were like really small in the picture. So you first of all, you needed like to locate that thing on a picture before predicting. I could be wrong.
Yeah, and there were some that were black and white only, and some were color and so on. That was another feature of that data set.
I think the winning solution from the playground competition first predicted like bounding boxes around the tails of the whale.
Yeah.
And that was part. So I think that if you look at the playground like first place solution, they have some discussion of that. But I do think that's going to be necessary in this one as well.
Yes, they hand label the entire data set. So they hand label the entire data set for the tails of the whale, and then they created their model on top of that.
A hand label? Wow.
Yep.
Wow.
Why wouldn't you label by the program?
Because you want to teach your program to label them, right? So you need to feed some data to it, right? So basically
they basically needed to create the bounding boxes because they didn't have that as like training data. So they first needed to actually make them themselves before they could train the model.
Yeah.
Yes.
Okay.
Exactly.
And even did they find that image augmentation helped in that playground competition?
So
I don't know about that. Yeah.
Yeah, so a lot of data augmentation that we did in terms of doing the transformations available within Fast.ai helped us improve the score a little bit, but didn't kind of take it up kind of further.
Okay.
So the important thing when you talk about bounding boxes is, yes, I think that is an approach we would like to take up and do, but the bounding box approach that we know of at least happens to be from the previous version of Fast.ai. I haven't seen the latest version and how the bounding boxes could relate to it. So that could be a challenge as well when we kind of take it up.
Yeah, what about, that's different topic a little bit, but the PyTorch 1.0 that was just released, is there an impact for the Fast.ai library, do you know? Or it just should work as normal?
You'll be able to run it on Windows now.
Oh, okay.
Are there instructions for how to install on a Windows machine yet? Or?
I've tried to install it today. PyTorch worked fine, no problem. But Fast.ai I also installed, but when I run lesson 6, the step where it's creating the CNN, it gave me an error, that the error in pickling the model or something like that. So I think Fast.ai is still not ready for Windows, not yet. I put in the forum this link. I will show you about how to install it, because I went through the process, but it's pretty easy. No, not a big deal.
Do you have GPU on your machine?
Yep.
Do you have GPU on your machine? Or?
Yeah, I have local GPU. Yeah.
I see.
But I try to use GCP because my machine is Windows. I cannot leave Windows, so I forced to use GCP in the whole course. This one. I will share the link in the chat.
Anyone trying human protein challenge?
Yeah, I'm in it right now. Yeah.
I'm using Williams starter pack.
Yep.
Yeah. Thanks for that. Sounds fun.
Okay.
Actually,
Yeah.
I don't understand it. I'm just using it because you had to quite a bit modify, right, the Fast.ai kind of the code that we saw in lessons, right?
Yeah. So
yeah.
basically I have two questions. So one is related to the Kaggle competition, one is in general. So first, so say you have trained your model. So it is not related to Kaggle competition. So I'm talking about the simple general scenarios. So say you have trained your model, you choose your architecture, you have tuned your hyperparameters, and you have did whatever you can do to make your model make your model to predict correctly. Now what else you can do to improve the accuracy except from ensembling? So basically in deep learning we have limited choices. We cannot we cannot do the feature engineering. We cannot do some kind of manual processing where in the same as in machine learning, where we can have some kind of hand labeled features to improve the accuracy. So how you can improve the accuracy of a trained model? So basically one way is to create the ensembles of the model, but that is not possible in the many production scenarios. So what else you can do to increase the accuracy?
Well, so you're saying you don't think you can ensemble, or?
No, I can obviously ensemble the models, but is there any way to improve the accuracy except for the ensemble way?
Hmm.
So I mean, basically, yeah.
I
Please
guess
go ahead.
one other thing people do is like finding the right threshold is, especially for that competition, I think. So like you're producing these outputs, but you obviously have to threshold them at some point to create your 0 or 1 prediction. And people have seen a lot of difference in that competition with different thresholds.
Okay, so this brings me to this second question. So in our human protein challenge, there's a huge class imbalance problem, right? So what I have seen in the public kernels, people are using some kind of models, let's say a linear model, to find the threshold for the prediction. Okay, so what if how do I say what so what if the test data have a different threshold?
Yeah, that's definitely a good question. I think for this competition, honestly, it's going to come down to a little bit of luck and some guesswork. Like, I don't think anybody knows what the private test distribution looks like, and so I think people are going to choose the models, and there might be a huge shakeup at the end. I think that's pretty likely based on the kind of what it looks like right now.
So basically, I tried to use the focal loss, so which is designed to work with the imbalanced data, but it didn't seem to improve the thing. So right now I am out of the choices, and the only choice that I have left is the ensemble of the model.
What is the name of the competition?
Human protein.
This is a human protein.
Oh, I see. So this is a multi-label competition, right? Or multi-class?
Yeah.
Multi-level, multi-class, both.
Multi-class. So I worked on the Planet competition before, and last year with Fast.ai version 0.7. So for multi-class, you have the threshold for each class that you can tweak it. So Jeremy, that time he used one threshold for all classes. I think you have a slight boost in the accuracy when you choose to make the threshold for each class different. So
yeah, I think that's right. Yeah.
Basically, we made a grid search. We tried all Of course, all combinations is cannot be done because the possibility is very high. But what you can do is that you make a for loop for the first one, and check all the values from a range, the lower to the highest range, and then you check for every number what is your accuracy, and you try to pick the best one, and then check the second class, the same thing, the third class, the same thing, until you reach the end of the classes. So you pick the each class a certain threshold. I think, but they didn't give too much enhancement in the accuracy, but it gives a little bit. Of course, the second way is ensembling. I try to make five parts of the training set. This is called CV ensembling. 20% divided, and choose to drop out 20% from the data, and combine all the five models that is trained on 80% of the data, but each data, you know, is different.
So guys, we are reaching the hour for the session now. So should we continue and discuss? Is that okay with all of you?
That is fine to me.
Yeah, it's okay for me also.
Yeah, it's fine.
Yeah, keep going.
So Heiner, for that competition, how many multi-class labels were there?
There's 28.
Oh, 28. So that's why you have to do a greedy search, simultaneous search for the thresholds.
Yes.
Yeah. I think it can be a little bit tricky to find like the threshold per class. Just because of the number of classes.
Yeah, I got for the planet competition to the top 3% with two tricks: the assembling, and with the thresholds for each class.
Yeah, but one more approach that I have in my mind for the assembling is, how about if we create 28 different models for each class and create 2 big models for all the classes, and in the end combine them? So using second order models like XGBoost or NMForest on this course of these 28 or 30 models.
You mean each model will make a detection whether this class is present or not, like this, and combine them? I think the multi-class model is already doing that, but it's combined all of them together in a single model. I don't know. You can try, but maybe it will not differ a lot. Because a model that is trying to predict 2080 class, it will differ only on the last 2 layers in the head of the model. It is the only difference that you will see. The last layer is instead of outputting 1, it will output 28.
Yeah, you're going to get the probabilities for each class, and then you're going to get 28 different probabilities, and then you just have to set the thresholds on each class to say whether you're going to make the assignment or not.
Yes, I mean you are choosing to use the same model exactly. Only it will differ with its final layer, which deciding how many classes you have. So I think it's one pony trick. There is no extra information that you will get if you choose 28 separate models, other than just you are repeating the same model. I don't know. This is my idea, but I'm not an expert, so maybe you can try.
Right? The last layer is the softmax layer, where it assigns the probability for each class, and that's the only thing that has to be different, right?
Yes, but if you want to get higher accuracies or higher performance, you should ensemble different types of models. That's the power of ensembling, after all. If you decide to use the same model, but only differ in the softmax layer, then you will not add any information. The power of ensembling is to use uncorrelated models together. So, one of the ways is that you check the correlation of the models in a confusion matrix before doing assembly. And choose the model that is not correlated. Yeah, I mean not correlated, that the result of a classification is different. You know, if all they agree, all the models that you are assembling agrees on those things and disagrees on those things, all them together, then assembling them will not take you any far away.
So how do you come up with this set of models? Is it cross validation? You just pick, like you were saying, that you randomly drop out to 20% of the data, and then you make one model, and then you take another random cut of 20% and you make another model, and then is that how you're reducing the correlations?
For this type of ensembling, you don't need to check for the correlation. You are tweaking the training data, so it will be different a little bit. But if you choose different models and you have a lot of models, then you pick up those that are not correlated. And in scikit-learn, there is an automatic way to check the outputs of models that you have and make a confusion matrix. So I did not do it like that, but I read a book about those things. So there are types of ensembling, assembling models, or stacking the output of models and do another model that is taking the output. And I mean there are a lot of types of ensemble, but I only worked on the CV ensembling, which is I described before here.
Yeah, CV meaning cross-validation, right? Is that what
yeah, cross-validation. You choose the first 20% and drop that from the training set, and the second and third and fifth, until you are collecting 5 same models but with different trainings.
Yes, yeah. And then average the results together, or
yeah.
Nice.
Yep. So what I have seen on some Kaggle kernels, they create 5 cross-validation sets, and they choose 3 architectures, and each architecture they train on all the 5 thresholds, which is different from what Heather is saying. So as per my understanding, Heather's approach is he created 5 cross-validations and choose 5 different architectures for each cross-validation part, right?
Yes.
But in some Kaggle kernels that I read, what they do generally, they create 5 cross-validation, they choose 3 different architectures, and for each architecture, they train on all those 5 cross-validations. So basically, for each architecture, they have 5 models, and if they have 3 architectures, they have total of 15 models. And on that, they do some hyperparameter tuning and some other parameter search.
Yeah, I think there is no hard rule for trying. Yeah, just there's some intuition that you try and pick up the best solution. There are many types of ensembling. I remember there are 5 types of ensembling. But there is no hard rule why you try this or that, as far as I know.
Okay. Good. Any other further discussions? Okay, so if there's no other discussions, then let's wind up and meet again next week. And possibly by next week, either we should have all of the competitions and the people who want to take those competitions identified, and we can kind of also discuss how we take that up as a regular cadence call bi-weekly with each of the participants, and who would like to go first and second and so forth. And hopefully we'll be able to collaborate together and make a fist of all of this and be better real experts ourselves, right? So thanks everybody for joining, and look forward to you guys joining again next week. Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you.